So my guest here today on Tech Talk is Joel Scotchfield. Great to see you, Joel.
You as well. Yeah.
So
Great to be back.
I know. So I want to use this Tech Talk to discuss the the technology and the general direction of inspection,
Okay.
and the Ko-Young roadmap, basically.
Sure.
So you are inspection is essentially the eyes and ears in on the factory floor.
Absolutely.
How do you see the technology changing, and how do you see the roadmap and development map for Ko-Young changing to adapt to that?
To accommodate that. No, it's a great question. And I like to refer to ourselves as smart factory enablers. I mean, that's really where we're going. We're providing solutions that enable the realization of smart factory, right?
Mm-hmm.
Which is what we're all trying to achieve.
Trying to achieve.
We're using our data set, which we know is a little bit different than others that are out there. Very measurement based, objective, ones and zeros, I like to say, right? And the copious amounts that we're able to extract to basically fire our proprietary AI engines to make our systems, much more less dependent on human intervention, right?
Right. And that dependency is not. It's not just a case of reducing the number of human interactions. It's also a case of improving the quality.
Absolutely. Yeah, absolutely. There's so many tentacles to this thing, Trevor, as you know, right? I mean, we're looking at this from a lot of different angles. The enablement of smart factory is one piece, but as we all know, the forecast for the labor situation that we're facing really globally, it plays a part in this as well, right? So we need a higher level of automation across the board for that smart factory realization. To do that, again, we have to utilize all of the tools that are available to us to make these systems able to basically judge, adjust, and accurately provide that pathway, right, to reduce the need for those people that we may not have the opportunity to access, right. For these reshoring activities, semiconductor activities, EV battery activities, which are going to take a lot of people, certainly.
Yeah.
Or a lot of automation, right? So we're looking at it from a couple different angles. One of the things that we've been working on for the last year or so is basically the complete overhaul of our software structure.
Okay.
And why are we doing that? Well, again, we have to be flexible. We have to be fast. We have to be able to handle a lot of data. And ideally, from a human intervention perspective, boy, wouldn't it be nice if when you walk up to an SPI machine, you walk up to an AOI machine, you walked up to the DPI, dispense process inspection system, they look the same.
Right.
All of the buttons for what you push to do this, that, and the other are all the same.
They have to be the same. They have to be intuitive,
Yeah,
and
exactly.
So that it's common across all machines.
Exactly, and it all ties back to, again, how do we reduce the need for human intervention?
Right.
So the AI piece is certainly a big part of that also, and as we've talked many times, we've made a very significant investment in that arena with our team in San Diego that's focused strictly on that, creating engines that use our data set specifically to in fact reduce human intervention at the programming level for AOI, and certainly in the case of print process control, the KPO tools,
Yes.
to look for trends, to look for anomalies, and be able to automatically adjust the squeegee speed, pressure, stencil snap off, etc.
Right.
And we're doing that, and that obviously, as you know, has taken some time.
Yeah.
It's a lot of data collection. It's a lot of analysis.
Yes.
It's a lot of algorithm creation and adjustment, retesting, regathering of data, reanalyzing, respinning of algorithms, and this is how it works. This is the kind of the generative path forward when trying to apply AI in this space.
In this space. Yeah, I mean, you've got the research facilities you mentioned down in San Diego, so it's working on AI paths to try and make all of this work faster, more seamlessly, and with less human interface, really.
That's exactly right, and we're seeing that, right? We're seeing that, and now we also then tie that into this respin, if you will, of the entire software structure. So it comes back to these tentacles that I was referring to. Everything is somewhat intertwined to a degree, but at the end of the day, it's all being done with the vision of knowing that to be successful manufacturing in the Americas, we have to have, and certainly in Europe and other high labor cost areas, we have to have this automation. The automation is different than automation we've utilized in the past. Going forward, it's really AI-driven automation now, and being in a position to take advantage of that, we feel gives us a significant differentiating advantage.
Okay. So, I mean, you've got lots of automation solutions at the moment, certainly on the line, but I think one of the most labor-intensive areas within the factory is the box build.
Yeah, you're absolutely right.
So what are you planning to do about that? Is that on the roadmap?
Yeah, it absolutely is, and again, that's back to the people conundrum, right?
Yeah.
The front end of the SMT lines today is very much not labor intensive, right? We've gotten things to the point where a single operator can oversee multiple lines up from the screen printer up through the reflow oven. But on the back end, that's not the case. That's where we still have a lot of people. So, kind of going back to the original, let's call it initiative from our perspective, right? How do we reduce the human element? We have to look at that as well. So, we have adapted our technology to be able to do just that. So, you'll be hearing more soon about a tool that basically takes our probe construction and puts that in a format that's adaptable to alternate access points, let's say, on the back end, right? Whether that be mounting it over a conveyor, potentially, on a robot arm, various applications that go on the back end that need that flexibility and adaptability. So, yeah, that's very much a big part, in my opinion, of the next wave of growth, both U.S., Mexico, you name it. I mean, it's everywhere. The problem is the same, and again, back to the reduction of need for the human element.
Okay. Another trend that's happening in the factories, Joel, is increasingly we're seeing contract manufacturers putting in clean rooms. There is a shortage of OSATs, for final assembly here.
Yeah,
and so some contract manufacturers are starting to bring some of that back-end packaging activity into the factory.
They are.
So how are you adapting to that requirement?
So we see that as a huge initiative as well. A little bit of a different conversation as it applies to the reshoring of semiconductor manufacturing in general, which, as you alluded to, brings a completely different set of challenges.
Yeah.
People, infrastructure. We just don't have it here. We really don't have it in Europe right now.
Right.
And so our push, our direction here is to, again, adapt our technology for the needs of that space as it grows, right? And it's going to take, I think, a little bit more time than people originally anticipated.
Right. But do you have the technical capability to be able to inspect all these very small devices, shiny devices at
Yes.
such a small
Yeah.
size.
Absolutely.
Essentially, you know,
Yeah.
and in some of these devices, you know, you look at 1 million connections. You
Yeah,
know,
you're absolutely right. And so again, kind of back to the respin of the software to be able to handle that increased volume of, let's say, 1 million plus pads on a
Yeah.
surface, starting with that. But then again, you get into that clean room. What are we doing, right? We're positioned now, Trevor, to basically handle everything post fab. So I have a completed wafer lithographies
Right.
finished. It's basically, I like to call it the circuit board of semiconductor, right?
Right.
So that OSAT's now going to take that and run with it, right? They're gonna dice it. They're gonna add their elements. They're gonna go down the heterogeneous path and move from 2D to 2.5 to 3D and stack and
Yeah.
do all these things with interposers and silicon glass. They're going to add again to
That
that
brings in-
chips and other
Yeah.
SMD type parts. So
Yeah.
with the Meister series, we feel we have again an advantage because we've been doing that and doing that very well for a long period of time, right, on the SMT side. So when we get into those heterogeneous to those hybrid type applications, now we have with the Meister D Plus the capability of handling the shiny reflective for micro cracks and FOD and other anomalies, in addition to all the other inspections that potentially need to be done that may be more related to what we've traditionally been doing with very small passive devices, et cetera. So,
Well, it's,
and with
yeah.
the W format of the Meister, able to handle that wafer, as I alluded to. So
Now,
that whole advanced packaging thing, right? That initiative.
Yeah. Now, as you mentioned just a moment ago there, it's also starting to go in the Z direction with
Yeah.
those stack dies and things
Yeah,
like that.
absolutely.
Which is, of course, very difficult for you to do with optical inspection. Have you thought about moving into other areas of inspection or test, to sort of give an end-to-end solution?
Yes. So again, something you'll be hearing more about soon is adapting that Meister system that I just described and some of the capabilities thereof even further to basically handle all the various forms of packaging that exist, right? So once that die comes out of the wafer and now it's placed in a tray and other things are happening. As I said, the whole heterogeneous piece where we're stacking and we're adding components and so forth, the needs change for inspection, right? The handling needs change, the inspection needs change. So handling is really the biggest part. The inspection side of things, I think we're in a pretty good spot. Obviously, increasing capability to go to smaller widths and line spacings and all of that is something we'll have to continue to work through. But I think the bigger challenge is the handling piece, and because
things are getting they're more fragile.
for sure, thinner. Again,
yeah.
glass.
Yeah.
I was at a conference a few weeks ago. A lot of discussion. Silicon or glass. Which way are we going to go? And there's advantages to both, but again, handling is different potentially for both.
Yeah.
So we have to be ready for all of that. So there's absolutely work being done right now to be able to adapt again the existing technology to the needs of that application.
Right. Well, you've certainly got a whole lot of challenges ahead of you, Joel. But,
We do. We do.
It's going to keep you busy.
But that's really what it's all about, right?
Yeah.
I mean, that's the growth that we're all looking for, right? If we're gonna realize, George Jetson's world, we're all gonna be here for a long time because it continues to evolve, right? More AI, more data, more automation, more cloud processing, more of all of this, which is a pretty cool thing, right? I mean, we're in a good space.
Yeah.
I think this industry is healthy and will continue to be for a long period of time.
Yeah. And I think KY is definitely, or Ko-Young is definitely in the right place at at the
We,
right time.
we like to think so,
Yeah.
but we always have our our ear to the ground,
ground.
and what's coming next,
Yep.
right? That's really what it's all about. And fortunately, we have a very, as you know, a broad spectrum of customers that are very involved in a lot of these initiatives.
Yeah.
All the AI players, and they bring us in early to these conversations to basically say, get ready for this,
Yeah.
because this is what's next.
Yeah.
And we ship this out to our OSATs or our EMS providers. They have to have the capability to handle it.
To handle it.
And and in our world, that becomes available for everyone, right?
Yeah.
We don't specialize for a specific customer. What we create for one is
Same,
to the benefit of all. Yeah.
Well, thank you for bringing us up to date with the roadmap, and we look
It's-
forward to seeing you execute it over the next few years.
That's the challenge. I look forward to continuing to provide updates as these steps are taken, and that's the exciting part of what we do.
Great.
Thank you for the opportunity to talk